Welcome back to another video on the Megger MTR105 rotating machine tester. In this video I'm going to take a look at the voltage function and compare it to the Keysight and the MetraHit. To do that I have a three-phase injection test set that can put out 0 to 600 volts and from DC up to 1 kilohertz. So I'll be able to look at the accuracy of the meters across that range. I'll then move on to the specific elements available within the voltage function of the Megger MTR105. So looking specifically at the MTR105, you can see here it has an AC DC mode, which is the one it defaults to. I can have an AC mode, which will also display the frequency, and I have a DC mode as well. I will just flick this to ohms on this one. So I've just set up the Keysight to measure the input impedance on the DC voltage function of the MTR105, and you can see it is bouncing around quite badly. So I'm not quite sure why it's doing that, but generally you like to see these things at around about 10 mega ohms so that it can be used with high voltage probes. So I wasn't expecting the impedance to be bouncing around like that at all. I'll reset the instruments with the MetraHit coil being measured by the Keysight and you will see the difference. So that's the same input impedance measurement being made on the MetraHit coil there, and you can see 11.11 mega ohms. Ideally should have been 10, but at least you can see on this instrument it is actually steady. Okay, after that little test I'll reset everything so we can make the actual voltage measurements. Alright, we'll start the test off. This is 25 volts up to 525 volts in 50 volt steps at 4 seconds per step, and the meters are all set to low pass filter mode, which is usually the most inaccurate of all the specifications. So I'll let this run through this test. I've done some other tests as well, which will be on DC, AC-DC mode, and I do a DC linearity test as well. And what you do tend to notice that the Megger is lagging behind the other two instruments by quite a noticeable amount, which is not good. Accuracy wise I don't think there's any issue with it, but its response, I guess for the instrument just aimed at measuring voltages on a motor, it's acceptable to a single capture, which I guess is what it's intended for, but the slow speed of the response did surprise me. Okay, so with this test I'm going to do some frequency measurements. You can see frequency is just a much smaller figure on the Megger, and it's only rated to go up to 400 Hertz. The other two instruments, frequency is much more prominent, but you don't get the voltage when you're measuring frequency with the MetraHit, whereas you get both with the Keysight. But what you can see in actual fact is the Megger did carry on reading the voltage even though the frequency went above its rating, which is quite good. Okay, that's that one done. We are now running a DC linearity test. This is from 20 volts down to minus 20 volts DC in 4 volt steps, a step every 4 seconds. So you can see the MetraHit has a few more digits at the higher end. You can still see that the Megger lags behind the other two instruments really. It gets a little bit better in the higher voltages. Yeah, it's a bit mixed, isn't it? Okay, so that's that test. I will put the results up in plots for all of the measurements that I've made. Accuracy wise, there doesn't appear to be any issues with the instruments. There's a bit of an issue over the speed at which the MTR105 responds, but on occasion for some of the measurements on some of the ranges you have a similar issue with the MetraHit. So the U1461A seems to have a better voltage measurement facility across the board. In some respects it is challenged in its accuracy in number of digits by the MetraHit, but it is better than the MTR105. But that is not the full story, because what I'm going to do now is use the unique three-phase facility on the MTR105 and demonstrate that, because what the MTR105 lacks in its performance it's going to make up for with the ability to measure three-phase. While you've been perusing the plots and tables of the voltage accuracy measurements, I've reconfigured the test set for a three-phase voltage measurement that the MTR105 can do, which the other two instruments cannot do, only by swapping over the leads. For the MTR105, all three leads are connected up, and to get to the three-phase measurement, it's just off this menu here, and there it is in front of you. And obviously you can see at the top as well, I'm also going to get phase rotation out of the instrument as well as the actual voltage readings. So I'll apply some volts and you can see what it looks like. We're set up for 400 volts, three phase, and you can see here obviously all three instruments fairly well matched, but using the other two I would now have to move the probes over. But with the MTR105 you've got a need for three-phase voltage measurement. There it is. At the top of the screen you've got the phase rotation as well. If I change over two of the leads you'll see the voltage drop off anyway. And put the light back on. And there you can see phase rotation has changed and all three voltage measurements are back. That three-phase rotation does come into its own with another function of the MTR105 as well for validating three-phase motor rotation, which we'll get into in another video. What we're going to do, if I drop the voltage down on one of the phases, it's reacting quite well. Yeah, so it matches the other instruments for an imbalanced phase measurement. So yeah, I feel that's quite a good feature really to have if you need to set up or want to measure voltage balance across something. The MTR105 can do that quite easily. It looks like the let's see what so the phase rotation doesn't appear to like it too much of an imbalance. Yeah, it drops out, doesn't it? Okay, not the end of the world. I mean, you're not going to have, if you've got that much of an imbalance on a three-phase system, you're not going to be worried about the direction of rotation, are you? So not too much of an issue really, I don't think. So we're at a point in another video where I dish out some points. For me, I really like the three-phase functionality of the MTR105. The voltage measurement and the phase rotation function coupled together is very, very useful for working on motors, and obviously neither of the other two instruments have that kind of functionality. I do accept that the update is a little bit slow on the Megger, and they really need to address that, to be honest. The other point to note with the Megger unit is that it's Cat 3 rated, whereas the other two units are Cat 4 rated. Working on a motor, that should be fine, but if you take that Megger into distribution boards, perhaps need to be just that little bit more careful, whereas the other two would afford that slightly higher level of protection. For me, the accuracy and the resolution on the MTR105 is fine. If I'm measuring 415 volts, I don't care if it's 415.5 or 415.7 or 110.6, whatever it is, I'm not worried about that. Obviously some people may feel different, but for me, for the kind of work that I do, I just don't need all the decimal points that the other two instruments offer, or I should say I very rarely need it, certainly when I'm not working on motors. For the other two instruments, The MetraHit is slightly more accurate than the Keysight when you average them out, but it won't display the frequency and the voltage at the same time, whereas the other two units do, and it also has a little bit of an issue with its updates on occasion. So from my point of view, I'm going to give 5 points to the Megger, 3 points to the Keysight, and 1 point to the MetraHit. And you can disagree with me down in the comments below if you like. Thanks for watching. I hope you enjoyed the video and it's been of some use. I'll see you in the next review video on the MTR105, where I'm going to look at some current measurements.